Hi everybody, it's 314Reactor here. Today's project, the parts were mainly supplied by dfrobot.com, so thank you to them. They contacted me last year. I wanted to make a robot project. I looked through some of their gear and I found the awesome Gladiator chassis, which is what I'm using for the HK project. For those of you familiar with Terminator, you'll know that a HK robot is either a ground-based or an air-based robot that was designed for hunting down humans in the Terminator films, all two of them. For those of you unfamiliar, that's basically what they are, just a killer robot from a maniacal group of machines from a hellish future apocalypse. So I thought it'd be a good idea to make one with an Arduino and a Raspberry Pi. As you can see here, the chassis is really cool, perfect for the kind of design, the track design that the Terminator HKs have, and it's really high quality. So again, thank you to dfrobot.com. Do check them out, there's a link in the description. Then they have all the parts you could think of, including the sensors here, the chassis itself, the Arduino, the motor controllers, pretty much everything you could need, and the Raspberry Pi as well. Really good company, really good stuff. Do check them out. So this video is going to go over some of the workings of the HK, seeing it move around, seeing it do its stuff. If you want to check out the code and the write-up for it, the links are all in the description to my Hackster, my Electromaker, my own blog page, and my GitHub, which has all the code on. So if you want to look for the instructions on how to build it and the code for it, check out those links down below. So let's take a closer look at the bot itself. As you can see, there's a number of sensors on it there. There's ultrasonic sensors on the front, and underneath that are two RGB LEDs. They're used for the plasma cannons, which can either fire red or purple plasma. There's a Raspberry Pi camera mounted on top there. There's another ultrasonic facing backwards. There's an ultrasonic underneath and underneath the back as well. All those ultrasonics are used to avoid objects because it can detect them. It bounces a ultrasonic signal off of objects, bounces back, it gets the distance from them, and using that information you can program it to avoid running into things, which from my testing, for the most part, it does, but we'll get to that in a bit. Got the Arduino there with the motor controller on top there. The Raspberry Pi there with a nice gold metallic case on it from Pimeroni. Do check those out as well. The Arduino and the motors are powered from 6 AA batteries, which are underneath this big battery pack here. This big battery pack here powers the Raspberry Pi. It's a 10,000 milliamp hour battery, and it can crank out 3 amps, which is what a Pi 4 needs when it's running heavy duty loads. There's another video, which I'll link in the description, that goes over the general construction of the Gladiator chassis itself, and at the end of that video you see a very early version of what this is, and since then, in the months after that, it's had a whole lot more put on it. Now, as you may remember before, I've made the Nvidianator, which was the Terminator skull with a Nvidia Jetson Nano inside of it and a Raspberry Pi camera. This was pretty cool. It had some detection stuff on it. It could speak, it could take human input and then respond using a built-in chatbot hooked up to a text-to-speech generator. The issue with this is that it was very much single task. If it was detecting an object, it couldn't listen. If it was speaking, it couldn't listen. If it was listening, it couldn't speak or detect objects. So it could only do one task at a time. So the HK software is a little bit more advanced. Working on the first iteration of an event queue that I've been working on, where essentially you have TTS or visual detection systems or movement systems or anything like that, all multi-threaded, all running at the same time, and when they want to perform an action, they send a request into this central event queue with a priority on it, and then the event queue works sequentially down through that, so you can have multiple things happening all at once without them having to sort of single task. So in future, when I put this onto a future Terminator head project, they'll be able to listen while also be able to analyze objects on the camera, and they'll also be able to push things to the TTS while still listening and performing visual analysis and then dropping the results of that into a queue. The results have been interesting so far, but it works pretty well. There's a lot of bugs that need resolving with it, but this is very much a platform that I'm going to keep working on over time, so there will be future videos and write-ups on this as I fix the software and add future things to it. But for now, essentially what it means is that unlike previous projects, it won't have to do one thing at a time. It can multi-thread, do multiple things at a time, and then drop all the results of those things, all the actions from those modules running into a central event queue that then allow it to respond sequentially depending on the priority. So that's really cool, and that is something that I can't wait to port to other projects as well. So as I mentioned, there's an Arduino on there. The Arduino handles all of the sensors, it handles the RGB LEDs, it handles all the lower level stuff such as object avoidance and movement, and it's powered off of these 6 AA batteries that are under here. This means that all the processing, the low level processing, is handled by the microcontroller. The Raspberry Pi doesn't really have to worry about it because all the motors and stuff are running off a completely different power system. it means the Raspberry Pi isn't at risk of browning out from lack of power, and the Pi itself, again, is powered off this massive battery pack, and the Pi handles all of the TensorFlow AI stuff from the camera, as well as other high-level AI stuff and the actual event queue itself. So essentially you have a two-layer system where the Arduino handles all the lower-level stuff and the Raspberry Pi handles the high-level stuff, and the Pi is plugged into the Arduino with a USB cable, and they talk to each other via serial, sending serial commands back and forth, so they know what each one's up to, and the Pi can request things for the Arduino to do, and the Arduino can pass serial commands back to the Raspberry Pi, telling it what it's doing, so that then it can respond accordingly. So this does have TensorFlow installed on it. At the moment it's got a standard train model that has a huge number of detections on it. It's able to detect objects and people. There's no further training that I've done on it, but in future I will apply some further training to it so it can learn individual people's faces and other more specific objects. This also uses YAML files for a lot of its configurations, so the visual configuration, the mission parameters, they're all configured by YAMLs. This allows things to not have to be hard-coded in Python, and it also enables the user to go in, change the contents of the YAMLs, so it can change the resolution that it's analyzing images at, it can change the frame rate, it can change the mission parameters that can be put into it, all while the program's running, so you don't have to shut it down and change variables within Python. So every minute or so it checks the YAMLs and then reloads the changes in, because that's another good advantage as well. It also makes deployment a bit easy for future projects, because I won't have to hard code wit.ai or Telegram API keys into the Python code. I can put them in a YAML and then just leave that YAML out of the GitHub upload, and other people can put their API keys into that YAML instead. And that's another thing that I'll be porting over to other projects in the future. So because this is a Raspberry Pi, it's got a lot of connectivity on it, including Wi-Fi. So this one is hooked up to my Wi-Fi, so you can VNC in and see an active feed of what the HK is seeing as it patrols around. We'll be looking into that in a few minutes in the video, and in future I also plan to put in extra UI functionality. There's a kind of stub there at the moment in the code on GitHub for a UI module. Doesn't do anything yet, but in future it will do. It'll allow you to fire up the visuals, it'll allow you to change mission parameters and other such things as well. So that's, again, something else that we looked into in the future. And when you're VNC'd in, you can run a debug mode, which we'll also look at. And also it will just show you the sort of visuals being outputted, much like a Terminator in the films. It will show you an event queue on the left of everything that it's doing. It will show you the confidence threshold of the TensorFlow object detection. It will show you serial reads coming in relatively real time from the Arduino, and the mission parameters as well. So I wanted to make it as Terminator-y vision as possible. Again, we'll have a look at that in a bit. Just moving around the lab here, and hopefully avoid objects. So at the moment it's kind of getting trapped in this corner here. So it's backing away when it's hitting the edge of that drawer there. There we go. As you can see, it's not always successful in detecting objects. It did slightly bump into that drawer there, but it's managed to get out. There we go, it's detected the edge of the bed there and has moved back. See how it handles this corner, so it's bumped into it, but it should detect that computer there. Hopefully it can back itself out of that corner. It's probably an example of where I need to connect little bumper switches to the front, so that it knows when the very front of it is hit, if it's hit something below where the ultrasonics can detect. But it appears to have got itself out of that corner okay. Using the ultrasonics on the front here, that one facing back, there's one under the front and under the back there as well, to make sure it doesn't run off edges and stuff. So what we're seeing there is just the bot moving around on the lower level stuff with the Arduino running. The Raspberry Pi is on, but the actual code that runs it I think has just kicked in now. So everything we've seen up to this point with the patrolling and moving around wasn't actually patrolling and moving around. It was just a lower level Arduino picking up on the sensors and making the bot move around to try and avoid objects. And now patrol mode should be enabled, which is the current standing order that's been set in the YAML on the Raspberry Pi. So now it should be actively moving around. See, there we go. It's bumped into an object there, but it's managed to avoid it and back away and turn around. Ooh. So there's one thing at the moment where when it's moving, it won't be actively detecting objects. It's only when it's not in a state of movement that it will detect an object. But it shouldn't move if there is an object within 20 centimeters, I think, of the ultrasonics. But that still can result in sometimes it bumping into things, which is where I need to get a better real-time analysis of the ultrasonic sensors to stop it bumping into things, and or put in some little impact detection switches. At the moment it should just be moving in one direction, spinning around, searching, and then moving around to another direction. So it should also have a standing order to attack any person on site. So if I get in front of its camera, next time it patrols around and faces me, hopefully it'll pick me up. And you'll see purple plasma come from the RGB LEDs. There we go. So it's detected me as a person there, fired off some plasma, just like the purple plasma in the films, and then it's decided to turn around and try to continue its patrol pattern. I think it might be getting a bit confused by the area that it's in. At the moment there's not a great way for it handling multiple detections on the ultrasonic. So if it's got stuff behind it and in front of it, it'll struggle to get out because it can't really do any movement. This is where it'll probably need some more advanced avoidance technique put into the Raspberry Pi itself, where it can do something a bit more clever to get out of these sort of situations, because it can override the Arduino and make it move, even if there are objects in the way, even if the Arduino is picking up too much stuff and it's kind of locked out. But at the moment it can get itself a little bit stuck in certain areas. With the patrolling standing order set, the Raspberry Pi is sending the patrol command to the Arduino every minute or so, and that causes it to go on the patrol pattern that's programmed into the Arduino. Still a bit buggy some of how these movements work and how the avoidance routine works, like I've said. So that's for in future. That will need some bug fixing. Oh, looks like it thought it detected a person there and fired upon it. Maybe it thought that dressing gown hanging down there was a person. Interesting. So at the moment it will just detect people. It can't detect specific faces, something that for future will need to be programmed in, as well as some more advanced routines for actions taken upon detections. But aside from getting stuck every now and then, it does seem to be patrolling pretty nicely. So the good thing about having the two-tiered system is that you can reboot the Pi and still have it take actions. So I was just trying to get it to shoot purple plasma, and it's not doing it despite the fact it is picking up detections. So I think that's a bug where it's possible the event queue is piled up to a point where the fire commands aren't being processed because the movement commands are possibly overriding them. I'm not sure. Oh, there we go. It's just decided to fire a bunch of plasma there. So yeah, there's a few bugs with it. I think a lot around the complexities of the event queue can be looked into. Since the Arduino is single tasked, I imagine the movement overrides when they're going. It's taking in a command to fire, but it's not able to do it because it's too busy processing a movement. So again, I'm going to have to find a way around that. Possibly program in some high level handling of such things on the Pi so that when it's moving, the Pi waits to send commands. There was something in the command queue that I tried doing with that before, but it resulted in a lot of spam into the overall event and command queues, and it kind of caused the robot to crash up. So again, that's something else that's there for the future to try and enhance it. It's quite complicated getting these queues working, and it's got itself stuck a bit there because obviously there's a lot of processing going on the Pi itself. There's a lot of command functions on the Arduino and they're talking to each other constantly. So here we are testing it at the edge of a desk, and it does want to keep trying to drive forward a little bit, but that sensor at the front should be detecting. Oh yeah, still trying to pull forward. Whoa! It's still trying to pull forward, even though that detector on the front should be detecting there's nothing underneath it. There we go, it's moved back. Whoa, let's move forward again. So the ultrasonics is still trying to move forward. So the ultrasonics on the back and front there, underneath, should be detecting when there's no surface in front of it and stopping it from moving. But something is happening there where that isn't working. That's another bug that I'm going to have to address. So here we are at the VNC side of things. This is the view from the Raspberry Pi itself. So if we go to running hkmain.py in debug mode, that should show a whole ton of information about exactly what it's doing. You can see it's loading up the standing order for patrol there, and the person terminate objective there. And after a few seconds, the visuals load up. Here we go, we have a live feed from the bot itself. You can see in the corner there, there's all the events that it's taken, the resolution at the top. There should be serial reads coming from the Arduino. That's not working at the moment for some reason. I'm going to try and unplug and replug the Arduino. Okay, so after rebooting the Arduino, we've got serial reads coming in. You can see all the actions that it's trying to take there. And it's just moved further into that corner of wires. Detected something there. Should hopefully back itself out. As you can see, I think there's conflicting reports from the sensors that's kind of got it cornered a little bit. Because as you can see in the serial reads, it's saying it's moving, turning right, turning left, stopping movement. And it seems to be doing multiple turns at once. I think that's where the problem is. As I said before, it can only handle 1 or 2 ultrasonic inputs. So it can get a little bit stuck, but it is working its way out. As you can see there. So again, I'm going to have to make that a bit smarter with how the Arduino handles detections. You can see the mission parameters there in the bottom right there. You can see in the very top left there, there's the frame rate, which is only about 2 FPS. So it will detect inanimate objects. Yeah, it thinks it's detected a potted plant there. So that resolution at the top is what it's using there, but I think the camera is capable of higher resolutions. But that does tend to slow down the TensorFlow processing. So it has some more accurate predictions. It's picking up a TV there, or a laptop there, it thinks. And it thinks that other monitor is also a TV. So it does have a reasonable ability to pick up on a good number of objects. I could program it to detect TVs and fire red plasma at them if I wanted it to. And then that would be like a primary objective there. If you set a secondary objective, then it will process the primary objectives first, then secondary, then tertiary. So it's a good way of layering up different orders to ensure that it does what you want it to with a priority. There's not much else it can do at the moment other than patrol and fire its plasma, but in future I plan to add a whole bunch of extra stuff to it. And there we go, it's detected me and targeted me for termination there. So again, that's just detected a person, not my specific face, but in future I do plan on retraining the model so that it can detect specific faces and more objects. And of course, one final thing to show off is the overall aesthetics of the UI. So I've got a nice sort of red Skynet desktop there, which looks really cool. And then in the corner, we've got the temperature of the CPU, the use of the CPU, and RAM usage as well. So that's very handy to have. So thanks for watching. That was my Terminator HK project. Like I said, there's a lot of future plans to it. There's a lot of bugs that need resolving with it that I found during testing and even during filming there. The event queue is still quite a new thing that I'm using, so that's going to need a lot of work and a lot of testing. Like I said, I plan on training the TensorFlow model with some extra stuff so it can detect specific people's faces. So I could have it try and terminate John Connor, as well as be able to detect all the other objects in that model that's already there. I also plan possibly put on a Husky lens in future, which is a really cool AI vision sensor. As we've seen, the Raspberry Pi processes about 2 frames a second, even a Pi 4 overclock. I think I've got about 200 megahertz overclock on it, and it still runs only just above 2 frames a second for visual detections at best, whereas a Husky lens has all of the hardware built into it for visual detections, and it runs about 30 frames a second. It can detect faces, it can be trained on new objects and new faces. So this would be really good to add in another layer on top of the system. So you'd have the Arduino running the lower level stuff, the Raspberry Pi running the higher level visual stuff, possibly still with the camera on it, so it can still feed vision back to the user via VNC, but you'd be using the Husky lens for object detections and people detections that it then reports back to the code in the Pi, and that would free up a lot of processing power on the Pi itself. So that's something else I could possibly put on this in future, but do keep an eye out for another project. DF Robot have just sent me a Husky lens, and I'll be definitely using that in another robotics project, so keep an eye out for that as well. And of course, as I mentioned, among all the bug fixes and possible hardware enhancements, there'll also be a UI in future. There's already a kind of visual UI as we've seen, but there'll also be a kind of menu where people will have to select what the robot's doing, override certain actions that it's performing, so you can get it to move forward if it gets stuck in a corner or anything like that. I'll see how that goes. Again, that'll be for a part 2 kind of video and write-ups, keep an eye out for that. So thanks again to DF Robot. Again, a link to them is in the description, dfrobot.com. You go there, you can check out all sorts of cool things, all the stuff that I used pretty much on the HK, as well as the Husky Lens AI vision sensor, which again, I'll be using in a future project. That was my Terminator HK project. Took me quite a while to do, quite a lot of new stuff that I learned from it, and there's a lot more that I need to learn from it in order to fix a lot of the bugs on it. So if you have any suggestions, if you look over the code of anything I could do better, please do let me know. Check out my Hackster and Electromaker pages. Drop me a follow there. Like and subscribe this video. Hit the little bell. Really helps the channel. And do keep an eye out for future tech videos and video gaming videos in general. I hope everyone's having a good new year. I hope everyone's staying safe. And I will see you in the next video.